Hello everyone. Today we are discussing on cloud computing reference architectures. Next slide. Uh, we'll be giving an introduction of this presentation. The NIST Cloud Computing Reference Architecture serves as a foundational framework for understanding the interfaces of cloud computing technologies and services. The high-level conceptual model provides a clear and comprehensive overview of cloud computing, focusing on actors, activities, and functions without being tied to specific vendor products or solutions. By facilitating discussions and development of cloud architectures, it aids in understanding operational complexities and supports the evaluation of standards and implementation choices. The objective of the presentation is cloud computing revolves around delivering services more efficiently and cost effectively to users. The primary objective is to provide faster and better services at reducing cost compared to traditional IT services that delivery methods. Instead of purchasing, maintaining, and managing hardware and infrastructure, cloud computing allows organizations to access computing resources as needed from a remote provider. This shift enables CIOs, IT project managers, and procurement authorities to focus on developing innovative client services, leveraging the flexibility and scalability offered by the cloud computing paradigm. Cloud Computing References Architecture. The NIST Cloud Computing Reference Architecture, which identifies the major actors, their activities and functions in cloud computing. The diagram is meant to make it easier to understand the requirements, users, characteristics, and standards of cloud computing. It shows a general high-level architecture where you can observe in the diagram there is a cloud consumers, cloud auditors, cloud providers as service like service layers are SaaS, PaaS, and IaaS, where you can see the cloud service management, security and privacy designs, and cloud broker, cloud carrier. The next slides will be giving an overview of this diagram and in detail of them by my friend Siva.
Hi, this is Shiva, and in this slide, we are going to talk about actors and their interactions in cloud computing. In cloud computing, several key actors interact to enable the delivery and consumption of services. These actors and interactions includes them. The reference architecture defines five major characters: cloud consumer, cloud provider, cloud auditor, cloud broker, and cloud carrier. Cloud consumer. These are individuals or organizations that utilize cloud services to fulfill their computing needs. They interact with cloud providers to access, deploy, and manage services through various interfaces, such as web portals or APIs. Cloud provider. These entities offer cloud services, including infrastructure, platforms, and many other consumers, which provides manage to underlying hardware, software, and networking infrastructure. Cloud auditor. Independent auditors or auditing firm access the security, performance, and compliance of cloud services. They conduct audits, reviews, and assessments to validate adherence to regularity requirements for the industry. Cloud broker. These are the entities whose act as intermediates between consumers and providers. Cloud carriers. Cloud carriers serves as an intermediate for connecting consumers and providers of cloud services. They enable access through devices like computers, mobile phones, and through using networks. The next slide will be continued by Hari.
Yeah, to continue with the service deployment models, in the world of cloud computing, deployment models play a crucial role in determining how computing resources are made available to the users. The public cloud model stands out for its accessibility via public network, offering a wide range of computing services to individuals and organizations like. In contrast, private clouds are dedicated exclusively to a single organization, providing a very higher level of control and security over data and operations. Community clouds bridge the gap, catering to the specific groups or communities with the shared interests or requirements, and can be managed either internally by the organizations themselves or by the third-party providers. Service orchestration. Uh, Service orchestration is behind the scenes magic that ensures seamless coordination and management of cloud infrastructure to deliver various cloud services effectively. It involves arranging and optimizing the allocation of computing resources, networking, and storage to meet the specific needs and demands of users and applications, all while ensuring reliability, scalability, and cost effectiveness. Now, let's delve into the service layer where cloud computing truly shines when its diverse range of offerings. Infrastructure as service, it's also known as IaaS, grants users on-demand access to fundamental computing resources such as virtual servers, storage, and networking components, and also allowing them to build and deploy their applications without the hassle of managing physical hardware. And next, a platform as a service. This takes things a step further by providing users with a fully managed platform for deploying, testing, and deploying applications, complete with middleware development tools by providing users with a fully managed and also the providing a runtime environments. Finally, the software as a service. It offers ready-to-use applications hosted in the cloud, eliminating the need for users to install, maintain, or manage any software on the devices. Each of these service models caters to different user requirements and levels of technical expertise, offering flexibility, scalability, and efficiency in the cloud computing landscape. Further slides will be continued by Spandana.
Hello everyone. Cloud service management. Cloud service management includes all of the service related functions that are necessary for the management and operation of those services required by or proposed to cloud consumers. And cloud service management can be described from the perspective of business support, provisioning, and configuration, and from the perspective of portability and interoperability requirements. And business support. Business support entails the set of business related services dealing with clients and supporting processes. It includes the components used to run business operations that are client facing. Customer management. Manage customer accounts, open, close, or terminate accounts, manage user profiles, manage customer relationships by providing point of contact and resolving customer issues and problems, etc. Contract management. Manage service contracts, set up or negotiate or close or terminate the contract, etc. Inventory management. Set up and manage service catalogs, etc. Accounting and billing. Manage customer billing information, send billing statements, process receipt payments, track invoices, etc. Reporting and auditing. Monitor user operations and generate reports, etc. Next will be continued by Shivani.
Hello everyone. Now I'm going to discuss about provisioning and configuration. Uh, Rapid provisioning automatically deploying cloud systems based on the requested services or resources. Resource changing, adjusting configuration assignment for repairs, upgrades, and joining new nodes into the cloud. Monitoring and reporting, discovering and monitoring virtual resources, monitoring cloud operations and events, and generating performance reports. Metering means providing a metering capability at some level of abstraction appropriate to a type of a service, for example, like storage, processing, and bandwidth. SLA management. SLA is nothing but a service level agreement which defines the quality of service that they offer their customers. These agreements provide providers with terms and conditions for factors such as uptime, response times, and data security, ensuring that both providers and users on the same page regarding the expectations. Next slide. Portability and interoperability. Uh, this section briefly discuss the requirement for portability and interoperability. For portability, customers are interested to know whether they can move their data across multiple cloud environments at low cost or and minimal disruption. From an interoperability perspective, users are concerned about the capability to communicate between multiple clouds. So the cloud providers should provide mechanism to support data portability, service interoperability, and system portability. The data portability is the ability of cloud consumers to copy data objects into or out of a cloud, or to use a disk for bulk data transfer. Service interoperability is the ability of cloud consumers to use their data and services across multiple cloud providers with unified management interface. System portability allows the migration of a fully stopped virtual machine instant or a machine image from one provider to another provider, or migrate applications and services and their contents from one service provider to another. Next, security. It is critical to recognize that security is a cross-cutting aspect of the architecture that spans across all layers of the reference model. Security in cloud computing architecture concerns is not under the cloud providers, but cloud consumers and other relevant actors as well. Cloud-based systems still need to address security requirements such as authentication, availability, authorization, confidentiality, identity management, integrity audit, and security policy management. The next slides are continued, my friend.
Hello everyone, my name is Saikmar. Now I'm explaining about the privacy in cloud computing. So the cloud provides protect personal information and personally identifiable information. Cloud providers are responsible for safeguarding your personal data like your name, address, or social security number, and personally identifiable information which can be used to identify you. And the cloud computing offers flexible solutions like the cloud computing allows people to access and share resources, software, and data over the internet. And it's like renting space on someone else's computer to store your files or run your program. The next slide. And the overall confusion of this assignment, the cloud computing reference architecture like an guidebook for understanding how cloud computing works. It breaks down who does what and how different types of cloud services are set up and managed. Roles in cloud computing are like there are different players involved, like the people or organizations using cloud services, for example, like consumers, and the providing the services like the providers, and the helping with managing or checking on things like auditors and carriers. The deployment models. The cloud services can be set up in different ways to fit different needs. They could be for everyone to use for organization and shared by a specific group like community, or mix of these like are called hybrid. And the service abstraction. This is like the organizing a team essentially to make sure everything runs smoothly in the cloud. And the cloud service management. It involves making sure cloud services meet the needs of businesses or users, setting them up properly and making them easy to move around if needed. Security roles. Everyone involves need to make sure cloud services are sure, but who does what depends on the type of services and how it's set up. Privacy protection, especially when dealing with personal information like your name or address, it's super important to make sure it stays private and safe in the cloud. Thank you, guys.